All right. Thank you, everyone, for coming. Yeah, my talk is called One Source to Rule Them All. Well, a couple of preliminary slides. Yeah, a couple of months ago, Andrei Breslov, inventor of Kotlin language, gave a bright talk here, and one of his main takeaways was from his talk was never create a new language. And I believe that his story of hard work for 10 years and complete exhaustion from this work is a good argument in favor of this take, never create a new language. But as any rule, this rule has exceptions. First is obvious, unless it's going to change the IT world, for example, unless it's going to be another Kotlin language. But the second one may be more applicable to our case, unless it's a domain-specific language. Because domain-specific language is something that is expected to be created during your normal projects, and many of you can benefit from this. So I'm Ivan. Currently I'm working as a staff engineer at company synthesize.io. Also, I'm teaching Java and data structures in Northeastern University, London. And today, I'm going to cover a feature of Kotlin, which is, I believe, somehow stands in the shadow. Because when people are talking about what's your favorite, what's the most prominent feature of Kotlin? Maybe coroutines, right? So everybody's talking about coroutines. Null safety, stuff like this. There are not many talks about DSLs. There are some talks. I'm going to give you some references in the end of my talk, but still not many. So I'm going to fill this gap today. Well, the first question is, what do we need DSLs for in the first place? Well, there is a common understanding that domain-specific languages, they are, unlike programming languages, they are clear, they are concise, they are understandable not only by programmers, but by subject matter experts as well. Well, this is in ideal world. In real world, it's a bit harsh truth of life is a bit more complicated. In practice, we can say that sometimes code can be written by a subject matter expert, not a programmer, if you are lucky enough to have a subject matter expert who is willing to write in your DSL, not in their plain English or some other language. But what's good is that often code can be read by a subject matter expert. So you're writing something as a programmer in DSL, and then you can verify your code with a subject matter expert, and yeah, it's a big deal actually. But the most important, I believe, feature, DSL feature, is that DSL code can work as the single source of truth for many tasks, aspects of the project. And I'm going to demonstrate this today during my coding and running section. So one source to rule them all. Okay, before we proceed with Kotlin DSLs, I'd like to theorize maybe and figure out the place of Kotlin DSLs in the field of DSLs. There is a quite a big and quite a thick book, this thick book by Martin Fowler about domain-specific languages. And in this book, they subdivide domain-specific languages into two categories, external and internal ones. External ones, they can be categorized further. So external ones are the languages that do not rely on some general purpose programming language. And the first category is languages designed from scratch. So you just, I don't know, design it, you create a parser, compiler from scratch for this language. And there are lots of examples. For example, Dot, Graphese language, Plant UML, GNU-plot, all the languages for building of graphs, of graphical languages, so they are examples of these languages. There is HashiCorp configuration language. HashiCorp developed it specifically for its products, and yeah, it's unlike any other. Another example might be Gherkin. It's Cucumber Frameworks language for behavior-driven testing. And again, this is a domain-specific language, not a general purpose, but it's a like programming language designed from scratch. Another category of external DSLs are DSLs based on some general-purpose markup language, namely JSON, YAML, or XML. So for YAML, I think we're all familiar with. So all the DevOps stuff now works on YAML. So it's open API specifications, GitHub Actions, Ansible, Kubernetes definitions. So all these are examples of external YAML-based DSLs. JSON also can be used for some front-end stuff, and XML. XML, well, it fell out of fashion maybe in recent years, but it's still quite powerful. It's well-designed, and XSLT is a powerful templating language on its own, and it's a subset of XML. Okay, so let's move to internal languages, the languages that rely on some general purpose programming language. And as we know, languages can be dynamically typed and statically typed. And with dynamically typed language, the interesting thing that historically, maybe the first internal DSLs were built on Lisp language. And there are a number of nice examples now, like not being actively used or developed, but historically they were first. Emacs, macros language, and some libraries for symbolic mathematics and stuff like this. Then goes Ruby. Ruby made like breakthrough in DSLs. There are lots of like frameworks for testing. RSpec is for infrastructure testing. Chef is like also for infrastructure as code. And Groovy. Groovy is more familiar for Java people. We have Spock, which is a testing framework, and other stuff, including Gradle DSLs, Gradle Groovy DSLs, and Jenkins files. So maybe some of you used Groovy DSLs. And then we are coming to statically typed languages. And what's interesting is that, well, it's not many examples of languages, statically typed languages, that allow us to build DSLs, actually. And most of them, like, not very widely used. Of course, Scala, Haskell, but they are, like, not very generically used, maybe, languages. And Kotlin. So Kotlin, in a way, unique language because it has features for building domain-specific languages, and still it can be widely used, and I don't know, like the learning curve is not very steep for this. So you can try and create a simple DSL in Kotlin right away. Okay, so since we figured out where Kotlin is on this like tree or categories, let's discuss drawbacks and advantages, because in engineering, nothing like comes for free. We have advantages and we have drawbacks, of course. Well, in terms of restrictions, of syntactic restrictions, of course, we are not restricted or limited when we are designing a language from scratch. It can be anything, right? We somehow restricted by language structure when we are working with dynamically typed languages like Groovy. But actually, we are quite free because, yeah, of course, every, I don't know, brace which is open must be closed in Groovy. But otherwise, you can type in nearly anything in Groovy, and Groovy will figure this out, like something meaningful. And you can write handlers, and this will be like a parser for your domain-specific language. So yes, from my experience, like Groovy is very very flexible in this way. When we're talking about JSON YAML XML, of course, we are limited by markup syntax. So our YAML DSL must be valid YAML. It's not, sometimes we want something more than this, right? And yeah, it's most complicated with statically typed languages, actually, because not only it must be syntactically correct in terms of the language, also type checking, also we must define all the identifiers when we use them, otherwise it won't compile. So maybe most restrictions are in statically typed DSLs. On the other hand, if we look for IDE support, nobody nowadays just type into text editor like Vim. Okay, some people prefer to code in Vim, but not many. So we want IDE and we want suggestions, code suggestions, and we want verification, right? So even before we start to compile it, execute, or do something with this, we want our IDE to underline all the mistakes to verify if it's okay or not. So, well, the worst news are for the languages designed from scratch. You also need to provide IDE plugins and stuff for your languages. So it's lots of work, actually. For dynamically typed, we have some rudimentary support. Again, it will check for basic syntax rules. It will check that all the open brace is like closed and braces are balanced, but not more, because IDE, because of the dynamic nature of the language, IDE cannot like infer or define which is correct and which is incorrect. We need to run the code, execute the code before we figure out is it correct code or not. So the support is quite poor. For JSON YAML XML, well, things are getting much better, because if we have XML schema or YAML schema, we will get validation, we will get suggestions, code suggestions, and it's better. And the best full support, I believe, is for statically typed languages, and we will see, like during our demo, that IDEA actually suggests valid options. Okay, so it was like flexibility versus IDE support. Another aspect is security concerns. Well, first and foremost, internal DSLs are executable code. So it's code in some programming language, and it's better not to execute it right away if you got it from the internet, from some untrusted person, right? So you might be safer, not might be, you are, of course, you are safer with external DSLs if you are getting these texts from untrusted parties, but not always. If you Google, for example, for billion laughs attacks, there are things called YAML bombs or XML bombs. It's like a short file, XML file, which is a valid XML. You are parsing it. If you are, of course, if you are careless enough to misconfigure your XML parser, and your XML parser blows up, and you've got successful DOS attack. So still, you're not completely, you're never completely safe. But of course, if you are going to create some, I don't know, some web services based on DSL, you have to think twice about internal DSLs. Okay, so now we figured out like the place of Kotlin DSLs. We figured out its drawbacks and we figured out its advantages. And now let's build one. Well, everybody who's talking about Kotlin DSLs, they say that we have like 8 or something, about 10 Kotlin language features, but it's better to demonstrate them right away, and that's what I'm going to do now. So let's look at some code. All right. So first start from bad example. By the way, the thing I'm going to show you here remotely resembles the actual code that we have in the product that I'm currently working on. So imagine we have a task to create an engine for some heuristics. So actually, you need to apply some rules, or run some transformation, run something based on some conditions. So if you have a set of conditions which is met, so like condition 1 met and condition 2 met, and run this, else, and so on and so forth. So of course, this is what every programmer starts with, right? Just if and else. But here we ended up with some spaghetti code. It's already quite clean, by the way, because in reality, we have mixed condition code here and execution code here. I extracted it to functions already. But you can, I think you can imagine how messy it can be in reality. And what's worse, so there is some knowledge, some domain-specific knowledge in this code, but we cannot share it with experts, right? We cannot verify because it's programming code. We may try to document it, but this documentation will be can easily be outdated. Just remove this and don't change your documentation, and it's out of sync. Okay, what should we do? We should refactor. First step, maybe better approach. We should refactor and use some patterns, design patterns, right? So the first design pattern that we can use is called strategy. So let's extract extract conditions, transformations, and rules into entities. So how can it work? Like condition actually, condition is actually an interface which has like its main function met, which is Boolean, which is either it's met or not met. What else? Transformation. It's also like an element. You can run transformation, right? And the rule. Rule is something that binds condition to transformation. So if the condition is met, then transformation is being run. So in our better example, we can build a set of conditions and transformation. And by the way, we can use like complex conditions like AND, right? So condition AND built from condition A and condition B is met if A and B are met. So this looks definitely better, right? And by the way, we are taking advantage of Kotlin language here, because if we wrote this in Java, it would have been like new, lots of like verbose stuff from Java language. So it's already, it looks quite good. And interesting thing, how do we run this? How do we implement? So now we have like list of rules, and so it can be like this. So find me a first null on which condition is met and run the respective transformation. So let's run it and make sure that it works. Come on. While Gradle builds everything, let me take another note. Okay. We have unresolved reference, but now it's going to be, okay. Transformation C invoked. So why it's invoked, we don't know. It's just we're hoping that we got everything right. So, but what we want is maybe, first of all, we want it just clearer and better syntax. Maybe we want it to look it like this. So this code, well, probably it can be shown to domain expert, right? So we have a set of rules. Condition 2 invokes transformation C. we are using these words, and they look like generic English words and phrases like condition 1 and not condition 3 invokes transformation A, and so on and so forth. And actually, this can be a valid Kotlin. This can be a valid Kotlin. And let's write just, it's just read because we haven't defined yet these rules, invokes, not, and stuff. So let's define and see how can we do this. Well, as you might probably understand, we have this word rules and braces here, which means this is a function which takes lambda as its only argument. So we must define a rule builder. So we must define a function called rules. But actually, DSL, what we are going to use here is another Kotlin feature called lambda with receiver, because inside this curly braces, we want to have a context, or we want to have some names defined inside these curly braces. So we can go like this. Let me quickly, just maybe to cut some time, let me just copy and paste and see, like this function, it takes as an argument a lambda, which works on the context called rule builder. So without this context, this is a normal lambda in Kotlin, and this is a lambda with receiver. So now, if we going to this and import this rules function, it's not read anymore. But what is read is this invokes, not, and stuff. So where should it be defined? This can be defined on the level of rule builder class, because rule builder is now the context of the DSL. So if we like type this, you see the type of this is rule builder here. Okay, so how do we do this? Just let me. So first, let's think of invokes function. So fun invokes. As we see in our example, we are thinking of conditions that invoke transformations, right? So it can be extension functions for interface, condition interface, and say invokes transformation. So let's define it this way, and we can put it like this. So now it compiles, but we don't want these dots here. We want it like to flow like a normal human language. For this, Kotlin has a feature called infix fun. So if we declare this fun as infix, then we can remove dot and remove this parenthesis. And now it works. So invokes. So actually invokes is extension function on condition interface defined inside the rule builder, which is the context of this lambda. I hope this makes sense. If it's not, it's okay. The examples are available on GitHub. I will provide you with a link. So what's it going to do? Just to cut some time, I'll just copy and paste. It's not, I need invokes, sorry. So invokes actually must, oh, come on. So invokes method does a very simple thing. It adds a new rule out of this, which is condition, and provide a generator. So it's just a builder. And again, to add some, to save some time for more interesting stuff, let me just copy and paste definition for other infix functions. They should go inside builder, of course. And you see, we can create an infix function called and, or infix function called or on condition, which will just build and object or object out of provided arguments. So when we go here, now it's not red. Now it compiles. So now this is how we defined all these functions and all these builders. So not a big deal actually, and we kind of built our own language because now we see like condition 1 and our IDE just suggests what can be done here, and other condition 4 like invokes, I don't know, transformation A. So okay, so far so good. But if it was just that, I could have just stopped at this point, and now we know how to build Kotlin DSLs. But I believe the most value is not in DSL like itself, is not in the syntax, but in the things that we can do once we defined our knowledge as an object that can be built. So first of all, if we look at our code, we see that the basic interface for rules, transformations, and condition is element. And this interface contains visit method, which means that we are going to heavily utilize visitor pattern. And visitor pattern is another design pattern which comes handy when we want to produce various outputs from a single data structure. So what do I mean, first of all? Well, first of all, let us like check that transformation C is still invoked. So our main use case is working. So we have DSL, we have this code, and this code is executable. So we're just finding first on null like rule where condition is met, and then we run this respective transformation. Okay, it's working. But what if we want to document it? In particular, we might want to visualize it because, well, maybe this makes sense, but it's better when it's like there is some graphical representation, right? So we can build like a function, visualization class, or visualization function, which can take, you see, visitor element, take this element, walk through all our elements, and transform them into another language, another domain-specific language, by the way, called dot. That's GraphVis. Anybody familiar with GraphVis? No? Nobody? Okay, I'm going to show you something. Okay, this is like main method, so I will run it just and see what happens. What just happened? This piece of code is like, you see the huge when switch between, if element is transformation, then we are printing a piece of code. If it's a basic condition, we are printing another piece of code. So what it does, it's actually a visitor pattern implemented to transpile our DSL code into some other language. And this language is called the dot language. This is like a tool called GraphVis. And this is specifically designed to visualize graphs. So this is just live representation of our code here. And you see here like nodes, and you see that some nodes are connected with arrows, but instantly we have visual representation of our set of rules, of our DSLs. And if I change something in my DSL, this picture will be changed automatically. So this is good. So no need anymore to like document your code, right? Because it's automatically, it can be automatically documented. If we are changing something, it's like reflected on this graph instantly. Cool, not only this. So we have the basic idea. So we have our DSL, now domain-specific language, and we can transpile it into other languages. Another more simplistic example might be like a documentation. So if we, again, it's very simplistic one. So we just looking for rules, and we want to describe each transformation in a language called ASCII Doctor. Anybody familiar with ASCII Doctor language? Okay. So ASCII Doctor is actually a markup language, but I think most of you are familiar with Markdown, right? So ASCII Doctor is just better Markdown. You can think of ASCII Doctor just of like more powerful, actually way more powerful than Markdown. But yeah, that's a topic for another talk, ASCII Doctor and stuff. Well, so our like tiny code example can be transpiled into this code, and this code can be then compiled into HTML, like here in this ASCII Doctor IDE, or into PDF file. And this is what actually my colleagues do on another project. So they have like very restrictive customers. They want like government related. They want like reports, formal reports, huge piles of paper, and actually it's better to have this automated. So if you have DSL and you can transpile it into ASCII Doctor and add some visualization and then produce these beautiful PDFs, it's one's boring task about like documenting is not boring anymore. It's not automatic, fully automatical. Okay, what else? Visualization, execution, serialization. So since our set of rules is nothing more than a set of objects interrelated, we can serialize them. For example, using Jackson serializer, and what do we have? We have YAML representation of the same DSL, or JSON representation for the same DSL, when it can be useful. For example, if you have front end and back end, and your front end in a way wants to represent or visualize your like setup, like your DSL, you can convert your Kotlin DSL into JSON, send it to front end, and front enders they know what to do with JSON, right? Or if you look at the other way around, you actually, in most cases, you have like a free version of your own DSL, not like Kotlin DSL, but YAML-based DSL. For example, if you want to make it available for like wider number of people who are not programming Kotlin, but some DevOps folks, right, who are using VS Code and YAML, they are YAML programmers, not Kotlin programmers. They can code YAML, you will code Kotlin. And this is like transpilable, one thing into the other thing. Oops. Okay. And what else? Well, I was talking about like the fact that DSLs are concise and clear and can be verified by domain experts and can be visualized and documented, but still you can make mistakes. And in this example, it's we can like say not condition 2 invokes whatever, And now this set of rules doesn't make sense. Why? Because since we are checking for conditions sequentially, either this condition is met or this condition is met, which means that these two lines of code are unreachable. So these two rules will never be executed. But most probably this is not what we want, right? So we want to somehow to check for this. And another aspect of DSLs, like what I most oftenly taking into account is testability. So we may write a test, sanity test, for our DSL. But here, like conditions and transformations, they are heavyweight objects. So in our case, in synthesized conditions are some facts about data in database. So you must execute a query in the database and figure this out. So you need a database, you need data in this database, and so on and so forth. Transformations, they are like transformations on data. But in order to verify sanity of these expressions, you don't need databases, you don't need data, you just do static checks, right? It's like static linter. You can build it yourself. For example, for sanity test, you can write a test that no rules are unreachable. For this, it can be tricky. Just let me explain. So we have a number of conditions. Condition. Sorry, where is it? Like you see, I'm using these sealed subclasses of conditions. So I know in advance what are subclasses because condition is a sealed interface in our scenario. We know, like in runtime, we know all the subclasses of condition class. And since all that we want to know about condition, if it's met or not met, if we have n conditions, we have 2 to the power of n possibilities for these conditions. And yeah, it's growing exponentially, of course, but still, if you have some about dozen conditions, it's doable. For dozen conditions, the full like traversal about all the possibilities is doable. So you just doing this like this expression is actually 2 to the power of condition size. I believe it makes sense for you, right? So we're just traversing via all possible expected combinations and check that at some point some rule is going to be invoked. Let me run this test because at some point I believe I spoiled my DSL. So you see, it's JUnit test and it's failed because well, we can say that the following rules are unreachable and blah blah blah. The following rules are unreachable. So let's get back to our DSL and remove this erroneous line and run this JUnit test, and it's green. All the rules are unreachable. And this is like the only, like we only just scratched the surface of what you can do with while statically checking your DSLs. So you can do amazing things. So you know like the meaning of your DSLs, you know what to verify, and you can write quite a big number of these sanity tests for your DSLs, and you can check them. Okay, let's get back to slides. No, it's not the correct slides. This one. Okay, so in a nutshell, I just demonstrated that one source can be used in execution, documentation, visualization, validation, and serialization. Like five use cases for one source. As some closing notes, I would like to consider some maybe advanced features of Kotlin DSLs. The first one is mixing DSL and code. Still, our DSL is code, right? So we can we'll import this and we'll have executable code. So, okay, like a basic condition is a subinterface of condition, and one of them is sealed. Yeah, basic condition is sealed interface. Okay, but condition itself, it's not sealed, and which means that we can implement just in the code inside the DSL. We can create like our own implementation, and as you can imagine, just any code may come here. So actually, we have an extension point in our code. Usually, we do this via creating in the rule builder something called custom condition or some custom method. So when we get to DSL, we can type it like custom condition and blah blah blah. Any code can go here. So when it might be useful, not everywhere, but there is quite common scenario when you're defining some state machines, like possible state transition. You have states of some document, for example, right? And this document, like approved, verified, I don't know what, can pass through states, and you define the state machine. And these states, allowed and disallowed states, sometimes you can just link them, but sometimes there is some business logic involved, in like when it's allowed or when it's not allowed to create this transition. So you can just mix your DSL and code in one place, in one file. Another thing, so infix functions don't work on this. For this example, I will need to shift example, because yeah, actually these conditions and transformations DSL is quite simplistic, and let's build maybe something more involved, a builder for a meetup program. So we have talks and we have speakers, right? And one talk can be delivered by more than one speaker. And what we probably would like to do is to put it like this: talk space delivered by. And you say, okay, let's go to Meetup Builder and let's make, it's already infixed, by the way. Let's make this function infix, but it's infixed. But what does it mean that it's infixed? It means that we can put like this, talk works on, talk is infix fun, not infix fun talk. So if we going here, we may say this talk 1 delivered by, and now it's compilable. But without this keyword, its infix magic doesn't work. And unfortunately, this is the limitation of Kotlin DSL, because in Groovy there is no such limitation. I believe if you are using Gradle, who's using Gradle? Like many of you, right? You have like what's it? A dependency, and in Kotlin you always have to put parentheses here. In Groovy you don't have to put, and exactly for this reason, that infix functions in Kotlin, they cannot work on this, but I can suggest a workaround for you. The workaround that we're using quite often. We can do it like this. Oops. What have I just done? I just overloaded the plus operator. And now it looks neater, right? But this plus operator, unary plus actually, the plus that comes before the object. So this one works, and yeah, you can have like shorter and neater DSLs as well by overloading operators, and they thanks God they don't require parentheses. Another like not always obvious feature is DSL marker. I don't know if we have DSL marker already. Oh, no, we don't have one. So if we go to our meetup DSL here, and inside talk context, it will still propose me to create a talk inside a talk. And it will be okay, like in terms of syntax, but this is not what you want, right? Because you want only talk to be only available at root context, and you don't want it to be available inside nested context. But for Kotlin, there are rules of scope, like variable scope or naming scopes. So you have like internal scope, which includes external scope. But specifically for DSLs, Kotlin has a magic annotation. Well, Kotlin has lots of magic annotations. And this is called DSL marker. If you create an annotation class and mark it as DSL marker, for example, we are creating meetup DSL, and let's like mark our builders as, so we actually have two builders, nested builders for meetup and for speakers here. Let's mark it with this annotation. You see it's already red. Because it's no longer allowed here, because now Kotlin compiler knows that, oh, now we are working in DSL mode, so you are restricted. DSL marker does not only this job. Recently, I've been told by Anton Arkhipov, who is a developer advocate for JetBrains, he told that actually they are using DSL marker, IntelliJ IDEA uses DSL marker to better support editing of your DSLs. So it's always a good idea to put DSL markers on your builders for your DSLs. But the ways they are using it, they are still undocumented. So we have to wait when they document it. That's just belief. So it's a good idea to use DSL marker annotation, and you will get extra help from IntelliJ IDEA in working with your DSLs. Okay, so I think this is like all the demo stuff I would like to show you. Some reading and watching suggestions. If you prefer to read books like I am, you may want to read a chapter in the book Kotlin in Action by Dmitry Zhemerov and Svetlana Isakova. They have a whole chapter about building Kotlin DSLs. If you want something as short as a blog post, I believe the best blog post on this topic is Ivan Osipov. He formerly worked for Kuba, now JMix platform, about Kotlin DSLs from theory to practice. Or if you prefer to watch videos, I already mentioned Anton Arkhipov, and I believe Anton did a talk at Brighton Kotlin, right? Okay, so yeah, you must be familiar with Anton. He has a number of talks about Kotlin DSLs, but there he only just shows how to prepare these builders. So where my talk is different, that I would like to show you what can be done further with all these visitor patterns and how you can transform it further. Some examples for your inspiration. So you might get like to your job tomorrow and think, okay, I want make some of my APIs DSL-ish. So what can be sourced for your inspiration? Of course, Gradle Kotlin DSL. Of course, Ktor framework. And Expose, there's an ORM for Kotlin. So I mean that it's not like you don't have to use it, but you can just see how they use Kotlin DSL and use it as examples of like well-designed Kotlin DSL's API. Okay, my conclusions. First, I think like I made it clear that DSL, domain-specific languages, internal DSLs, combined with design patterns, is a powerful tool for solving multiple tasks. The tasks that may be unsolvable by other means. Creating DSLs like is not scary, and it's actually very easy. So you can improve parts of your code, making it DSL-ish just right away. Just drop infix here and there, and you see that it will look neater. And of course, internal Kotlin DSLs are not the only way to implement DSLs. So you saw my categorizations, just 4 big categories, and Kotlin DSLs, they just one tiny category. There are other options as well. But definitely, it's not the worst in many scenarios. Thank you for listening. All the code and slides are available here on GitHub. So you can download it, and there are both code and slides available. Thank you for listening. You can contact me and ask anything. Thank you.